Hello everyone, Anthony here once again with episode 5 of creating a blockchain, a modular blockchain from scratch, where we will create a complete modular production ready blockchain that can compete with all the others from scratch, from a blank page in Golang. Okay, so let's see, where did we finished last episode? Episode 4. So we added signing and verification of blocks and transactions. That was needed because this episode, which is going to be a very interesting one, is where we actually going to code the internal blockchain structure itself, data structure. It's very important. It's the core because we will need to add blocks, maintain a list of headers, and basically a way to persist them and retrieve them. So yeah. For the people that want to follow along, I have everything on my GitHub page, which is in the link in below. And you can basically, I created a tag for every episode, git tag, where you can just check out that tag and follow along with that respective episode. So let's get started. So what do we need? We're gonna create a new file, blockchain.go. Core, yes, that's true. Type blockchain struct. So I'm gonna make it a struct for now. The better approach is to make this an interface, but because I don't really actually know what kind of methods we need to expose for that interface, I'm gonna code it as a struct right now, and then later on we will see what the interface should look like. Nice. Maybe we should also make a new file and call this blockchain test.go. Just always a good practice. This is not true. Package rather. Okay, cool. Open a blockchain. Then go. Package score. What's going on? Nothing. So blockchain. It is going to be a complex one. So we need a list of headers, which is going to be a slice of pointers to headers, and that's exactly why we changed this in the previous episode. If you see block, you see this as a header, and because you know, if we have like 200k or even more blocks in our chain, we're not gonna basically, if you want to verify stuff and retrieve stuff, we don't want to go onto disk each single time. So that's why we maintain a list in memory, because RAM is basically very cheap, and I'm going to make it more RAM intensive than disk intensive, because RAM is so cheap these days, especially if you're an engineer. RAM is nothing. So we're going to keep everything into memory, and to make it a little bit of efficient, we're going to use pointers instead of the whole shebang of a header. So yeah. You also need something like a store or a DB. Let's call it store. And that should be an interface. So maybe we should create a new file. Storage.go. Package core. And we call this storage interface. And we're gonna leave it open for now. Excuse me, I'm a little bit of a cold. Well, it's not a cold, it's an allergic reaction to my grass, which is just finished mowing. Okay, we're getting distracted. Blockchain. Yeah. So we need a store, which is a storage. And we need a lot of other things. But let's just get started. So, yeah, what we need is, the first thing we basically definitely need is a way to retrieve the height of the chain. And it's gonna be, yeah, a UN32, because it cannot be 0. And that's gonna be BC, it's going to be the length of all the headers minus 1. And of course, we need to make this a UN32 like this. So let me explain. So let's say we have Genesis block 1, 2, and block 3. Then we could say that this is has a length of 4, right? 4 length. But the height of the chain, so if we take this last block, the height is 3. So we can assume that if we copy this, that the height is going to be 3. And that's why we need to subtract 1. Height. Next thing, BC, blockchain, add block. It's going to be a block, and that's going to, please, going to return an error. Let's return null for now. And let me take a little sip of my coffee. Boost up my brains a little bit. Add block. Something very important is we need a validator also. Because basically what's going to happen, before we add a block, we need to validate if this block is valid, of course. So we could assume that we need a validator, which is a validator. And a validator, we should create an own file for it. Validator.go. Cool. Package core. Type. Let's close this. Validator. Interface. Yeah. Interface rather. Validate block maybe. Because it could be that validator could, the most logic way is to call it validator.validate, but we never know. Maybe we want to validate something else, validate header or something. So we're gonna do this. It's gonna be a block and it will return an error. And the same thing, the same principle as, basically the reason why we do this as an interface is we can mock it first thing for testing. And we can make a stub out of it, and we could use a default validator, which is the default validator of the chain if you don't configure another one. People can make any kinds of validator they want. So let's make, let's call it block validator. And we're gonna call it as a struct, maybe. And then say, wait. The block validator needs the BC, which is a blockchain. And for now, it's going to be the struct explicit, but it should be an interface. But that's for later on. So we could say here, v, block validator validates block. Error. Return null. And we're good. Maybe we should do kind of a constructor-ish thing. New block validator. Return block validators need a blockchain. And we say BC is BC. So we need to make a constructor for this, and we can actually go to our test. Yeah, let's just make something so we can play around with this. Like this. Think a new blockchain. The question rather is, should we pipe in a validator or not? BC is going to be a blockchain, and headers is going to be a slice of pointer to header, and the thing is we cannot put in a validator right here because the validator depends on the blockchain, and if we construct a blockchain we don't have the blockchain, so we cannot we cannot construct a validator. So it's a little bit of a thing, but a practice, what you see all the time is doing something like this. And then say something like validator is a new block validator, and we do in BC and we return, and we call it a day. Return BC rather. Like this. Okay. The thing is, this is basically explicitly called, so what if we wanna swap this out? Yeah, we could do something like this. So blockchain, if we want to configure this, actually, this should BC and validator should be constructed from a config file. So every default interface implementation should be constructed from a config file. So if people want to replace it, they just swap it out in the config. But we could also do it like this: set validator, and then just say BC and validator is v, something like this. That could also work. Why not? If you want to do it more programmatically. Okay, let's just say BC is new blockchain. And let's do not null, BC and validator actually. Of course. Alright, we're good. Just a good start to do this. Add block. So, yeah, we need to open up our validators. Valid block. Let's do this implementation. So, if there is a new block in the chain, a couple things we need to do. Of course, we need to check if it's if the transaction, if the integrity of the block is valid, and check its signature, along with the public key of the validator. The problem is that operation is very expensive. So before we do that check, we're gonna do a couple other checks, and we need to make sure that if we insert a block, basically append a block to the blockchain, that the height of the block cannot be higher than, so it cannot be lower than the current height. That's for sure, because that will means that we already have that block, and we cannot, I'm thinking out loud, right? And we cannot add blocks that are higher than the current height plus 1. That's what I think. So let's create a function where we're gonna say has block, and that should be a height UN32 with a bool, and we're gonna say a return a height of the block is smaller and BC pin couldn't hide. And actually before, yeah. But this can have some issues, because for people that actually are thinking a little bit deeper, a uint32 is initialized. Well, initialized basically is going to be a very, very large number. Which means that if there is no block in the system, I will show you actually. Let me show you. Let's get some teaching done. Blockchain test. Yeah, here. Yeah, so let's first print out BC print height. Okay? So what Go basically does is, you don't need to initialize the fields. Go will initialize every single value, except pointers, of course. And that's why it's dangerous, because you could have a null pointer to reference. But Go will initialize every single value to its original initial value. For example, an int will be 0, a bool will be false, a string is an empty string, you know what I mean? So, and a byte is an empty byte. So basically, but uint is different. So let's just do this. It's not gonna work. I will press this one. You see, this is our height, and that's an issue, because our logic will not work, because has block will always be true, even if we insert a new block, and we need to be aware of this. But it's always you could say, why don't use int? Well, the problem is the height can never be negative. So you could do a check, but why do a check if you could use a uint, which basically makes sure that you will never ever have some kind of retarded developer that will put -1 into a block. The system will crash if somebody puts -1 somewhere. So, and it's basically smaller, right? I mean, a uint. So the way we're gonna solve this, or the way we could solve this, is by something we really need to do, is add a genesis block. And for the people that don't know, a genesis block is always the first block in the blockchain. And that is most likely, basically always a how can I say this? A predefined block with some initial state. Because a blockchain is basically a state machine that transitions from one state to another each and every single transaction that comes in. But you need to have an initial state, and that's exactly what the genesis block is doing. So you could say genesis, which is a block, and let me quickly think. So we can add a genesis block, and a genesis block will not go through add block, because then we will be in trouble. So we should write a function, an internal function rather, like BC blockchain at genesis block B block. And we're gonna say, wait, I have a better idea also, like do something BC blockchain. Come on, please. Please. BC blockchain add block. So we already have an add block, but that's an exposed add block. We're gonna have an internal add block. Maybe we could do make it explicit, add block without validation. To make it explicit, always good to name your variables as pragmatic, as explicit as possible. Add block without validation, B block. I'm gonna say BC print headers. We're gonna to append the header. Maybe we should do a little bit of validation though, but and then let's go to storage because I really want to. We're gonna say put a block error. Could also say get. Well, actually, that's for later on. So bc.store and put b. Maybe we should make it an error right now. Add block without validation. And why is it complain? Yeah, it's unused. Okay, boy, smart ass. And then we don't need this function. We could say if we instantiate this blockchain, we could just assume, and it probably will change in the future. We will add more robust things to it, but for now, let's close it here. BC, an add block without validation, Genesis. We should return an error. Yeah, I like it. But now we are stuck in our tests. So we could do this. Maybe we should make a Genesis block or something, or we do random block 0, right? Yeah. Okay. Come on, please, Visual Studio Code, come on. I gave you the chance to come into my life, so please behave. Make test. All right. Yeah, of course. Damn it, we need to, for now, we're gonna say store. Just to make things smooth, you know, to make things nice and flowy, we're gonna say that this is gonna be memstore storage rather, and we're gonna say type memstore memory store actually, which is a struct, and we say we're gonna make it our own memory store as our testable quick and easy thing. So we're gonna say memstore memory store with b block error. For now, we're not gonna worry about any kind of persistence, so we're gonna return nil. But if we have this, we can do. Wait, let's make it good. Actually, why not? Storage func new mem store pointer to memory store, and we return mem. Exactly. All right. So now it's gonna call put, but yeah, mocking things up. Blockchain test. Okay, cool. So now it should work. I think. All right, we are good. Maybe we should test that assert BC and height should be 1, right? No, 2. 0. Damn it. Yeah. Because we added the Genesis block, and that will save us from this weird uint32 value, default value. Test it. Alright, you see, this is working perfectly fine. And let's take a quick sip of the coffee, of course. Lovely. Yes, yes, yes. Yes, now hash block should work. Yeah. Maybe we can test blockchain. Maybe we can do test new blockchain. Call it a little bit better. And make a new test. Hash block maybe. So, a matter of fact, we're gonna do something else. What I most of the time do when I'm testing stuff is it's very tedious to do in every single test create a new blockchain and oh my god and checking the error, and it's what we could do is make a function like a helper function, new blockchain with Genesis. Be passing testing .t so we can assert on the instantiation. Instantiation, oh my goodness. You know what I mean, right? Please don't roast me. New blockchain with Genesis, so gonna be a blockchain, yeah. I'm gonna say this, wait, we're gonna copy this, and even copy this, and just return the BC. And instead of this garbage, we can say BC is new blockchain with Genesis, and we give it T, and we're Gucci. And we can do the same thing with test hash block. So now we're gonna just assert false, no, true, and we're gonna say that we have this block. Wait, hash block. Yeah. Make test. Should be true, but it's false. Yeah, of course. No, wait. 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 It should be this, right? So smaller, of course. If it's smaller, then we are at -1. So if you have 0, smaller equal. That's gonna be it. Yeah, fine. So to test this a little bit more in depth, we're gonna add the block. To be honest, first of all, we're gonna say bc.validator.validate block, which is this block. And we're gonna return the error. And if there is no error, we could safely say BC add block without validation, because the validation has already been done. In this case, we don't need to be right, yeah. don't need to double write our logic for actually inserting it. And we could have some more validations, to be honest, in this thing, but for now it's good. BC add block without validation. And we return it. And test that block. Testing T, yeah. Like this, come on. Copy this bad boy. Block, new. Random block rather, and we're gonna give it 1. And then we're gonna assert BC and add block. Again, the block. Please, come on. Yeah, good. And then we want to assert, maybe, wait a minute, I have a better idea. So instead of doing this, what gonna do? Oh yeah, we're gonna do it like this. Let's say thousands. And this should be I plus 1, and we're gonna assert nothing. All right, let's call it from here. Cool. And then we're gonna say here assert equal T. So recap, we add the we create a new blockchain with a genesis block. So the height is 0. Then we added 1,000 blocks, which basically means that the length of our headers is 1001, but the height should be 1000. And then actually we could do len blocks. It's going to be 1000. This len blocks, and probably he's gonna complain because it's not a U in 32. Let's test this. Nice. And maybe to be certain, we could say just, you never know, PC pint headers should be len blocks. Right. Oh yeah, I'm an idiot. It's confusing sometimes. Yeah, all right, cool. But now, this is in the ideal scenario. We also need to make sure that we don't add other blocks that cannot be added. For example, let's say, so we added this 1,000 blocks, and let's say we do something like this. BC add block. Let's give it, I want to add block 989 for example. Yeah, I'm confused. Random block 89. Yeah, like this. I don't think that's gonna fail. Yeah. So it's basically adding this block, and we can't. That's a bad. So we need to go back to our validator and fix up these things. Validator. First of all, we're gonna say, wait, if v.bc.hasBlock b.height return help chain already contains block with hash is yeah, this Vim plugin, it's good, but it's not the best. Block is b.height, and then we say b.hash, and we need to have a default hasher, I guess. How was it called? Oh man, hashes. Block hashes. All right. Yeah. And we are at 36 minutes. So we probably need to split out this blockchain. It's going to be spread over multiple episodes because this is too complex and too important to do very quick and to encapsulate in 45 minutes. What was I doing? Okay, cool. So now this should be not nil, right? So yeah, so this should throw an error. Okay, and now it's good because we swapped it out, right? So it's not nil, so this test is passing. We cannot do this. That's nice. Okay. The next thing we need to do is, so we cannot add blocks that are already existing. Wait, I'm thinking, because what if somebody, but that's the validation part. Okay. So we're gonna say if b verify. What does verify actually do? I forgot. An error. Okay, cool. We're going to verify the block and we're going to return the error. So if we add a corrupt block, we don't add it to the chain. And I'm thinking a little bit deeper. Like I said, this is going to be a placeholder stuff. I'm 100% sure there's a lot of other stuff that needs to be added, but we cannot do everything in one go. Verify, yeah. So let's open up our test again. I think, yeah. So everything is failing, and the reason is a block has no signature, and that's nice. I'm happy that this happened. So that's because we do a new random block, right? And a new random block is making a header and then a transaction. Then we're gonna say BC. Wait, let's make a helper function, a random block with signature, and we pass in and a height. Yeah, there's a block, random block with signature, which is gonna call a random block, and then we're gonna say, wait, are we going to add a private key, or are we going to embed the private key into this function? I think it's gonna be much better to add a private key in here so we could test that, but yeah, let's just create it in here for now. We will change it up. Crypto generate private key, receive and sign, and that's exactly why we need the previous episode where we implemented those functions. Before we did this, we're gonna sign with the private key. We're gonna assert like this. Oh man. Okay. And then we return the block. No, wait, BC. Why is it calling BC? Let's call it B. Like this. Yeah. And then random block with signature, and then the only thing we need to do is add T inside of this one, and we're good. And see if this is working. Yeah, this is fine. Cool. Nice. Looking good. Yeah, so I think we're gonna just enable to cut these videos into multiple parts. I think this episode is already a good start, where we laid out a lot of things. Of course, there's a lot of work that needs to be done. Just to recap, we have our blockchain, which basically we can construct with a Genesis block. For now, it's just a simple block. No transactions in it, is a placeholder. That will set our height to 0. We have a validator, a default validator. We can add blocks. The validator will validate them. And we created some kind of a memory store, which we need to expand, probably next episode. Yeah, so far so good. And again, if you like what you see, and you see what you like, please hit the thumbs up and subscribe to the channel. Thanks for watching, and see you in the next one. Peace.